Our experiment is designed to minimize the power consumption of a computer or extend the battery life of a laptop. The parameter in question is the processor speed. Specifically, we are testing to see if the frequency of the processor can impact the power usage. We did this by manually changing the processor speed and by running a standard load test.
So here once again is the Linux terminal, and we are going to be running all of our commands here. This is where we're going to start the test and also get all of our relevant data from. So first, we type in sudo CPU power frequency set --freak 1,500,000 kilohertz equaling 1.5 gigahertz. This program CPU power sets all of the CPU cores to this frequency, and it measures the frequency in kilohertz. Sudo gives it the ability to make hardware changes by elevating its permissions. Here you can see that it sets 4 CPUs, counting first from 0 and ending in 3. This is because my laptop has a quad-core processor. Here we just make sure that the frequency settings have been taken. And now we check the current status of the battery. It's currently discharging, meaning it's not plugged in, and it has 45% remaining, around 3 hours. Next we run the actual test. Here we use Sysbench, which is a CPU benchmarking tool. We tell it to test the CPU for calculating prime numbers up to the number 20,000. Finally, we tell it to run that program. Now we'll let it run its calculations until it finishes. Now that it's finished calculating, we can get some data. It tells us that it took 53.7 seconds to complete. Next, we run the battery program again to get the resulting battery after the test. And we see that the battery percentage has dropped to 44%.
So, James just illustrated how each trial works. The frequency is changed in each trial, and in the second part of our experiment, we run a different load test while changing the frequencies the same as in the first time. Bree will now talk about the data and what it means.
So in our first set of data, we used the stress test of calculating primes up to 40,000. The data shows that we used a greater amount of battery because we did the test on a small netbook. So the test took up a greater percentage of that netbook's battery. Later we did it on a larger laptop, so the numbers hover around like 3 to 2 instead of the data in the first test where the numbers hover around like 5 to 4, just because of the size of the laptop. From this first set of data, we reached kind of a pattern that continues through all the sets of data, which is that the lower the CPU frequency, the greater the percent of the battery used. So for example, in the first set of data, 1 gigahertz, running your CPU at 1 gigahertz uses 5% of your batteries. Your CPU at 1.6 gigahertz will use 4% of your battery. So when you look at our second set of data, our stress test was calculating primes up to 80,000, so we just increased the load on the computer. Again, we found the pattern of the lower the frequency, the greater percent of battery used. Running your CPU at 0.8 gigahertz to calculate the 80,000 primes takes up 3% of this particular computer's battery. It dropped down to 2% by 1 gigahertz, and stayed there up until 1.8 gigahertz. So we had a slow change, and really what we're looking at is not so much how much of your battery was used, because that will depend on the computer you're using, but really the difference between what was used and what was not at different frequencies. So in our third set of data, our stress test was calculating primes up to 100,000. Again, we found the higher the frequency used, the less the battery's usage. But this time, because the load was much bigger, the numbers hovered between 4, 3, and then down to 2. Because the stress test was larger, the decline in battery usage was steeper, which is why you see that number in the best fit line for the slope of the best fit line being much larger than it was in the second set of data, just because the stress test was larger. possibly because more time was spent calculating so many primes in the third set of data. So what we concluded from this data was that the time saved by running your CPU at higher frequencies causes you to expend less battery power, which if you were expecting you to use more of your battery calculating at higher frequencies because you're just going much faster, that's not the case. So the higher frequency you use, the less battery you use because you get the job done quicker. However, we also concluded that really the difference between the drops in power usage for the different CPUs was not very significant at all. So what we concluded was that CPU frequency does not really have a major significant effect on a laptop's battery usage, and instead other factors like screen brightness and hard drive usage might play a bigger role in the amount of battery that your computer expends.
So, just to summarize the experiment, by testing the computer under different loads and frequencies, we've determined that the CPU does not significantly impact the battery or power usage, which must be more related to other parts of the computer. This means that running your computer at a higher frequency will allow you to accomplish your task faster without significantly detrimenting your battery life or power usage.